Okay, question 4 says the graph of f of x is equal to log 1 divided by 3 to the power of x is drawn below. Point A, it is the x-intercept of f, and 3t lies on f. Remember, the coordinate of A are just the x-intercept, and it's going to be 1 and 0. Okay, yes. Calculate the value of t. How can I calculate the value of t? So I just need to substitute into my formula. So I'm going to say y, it is t, and then log 1 divided by 3 to the power of x, it is 3. And what I normally tell my students is that when you have y, it is equal to log a to the power of x, when you're trying to solve for x, just say x, it is equal to, and then these two will swap the positions, and then it's going to be a, just write a as it is, and then swap x and y. Okay, so x is already swapped here, so it's just a matter of swiping y. Okay, so similarly here we're going to say I'm solving for what? Oh, in this case I'm solving for t. It's easy. Okay. Or in case t was here, you're gonna follow that analogy there off. Okay, so this one just needs you to punch your calculator, and then how much do we get? Log 1/3 all raised to the power of 3, -1. So we get that t has a coordinate of 3 and -1. Okay, not bad. Write down the coordinate of a. That one we know of by heart, 1 and 0. Okay, 1 and 0. If you're not sure, you can let y equal to 0 and then become a mathematician. Okay, yes. Determine the inverse. Okay, the equation of the inverse in the form of y. Well, it's easy. Every time when you have log, let's say f of x, it is equal to log a to the power of x. Its inverse is going to just be a to the power of x. Only this part without log. Okay, so it's easy. This one, I won't do the swapping of x and y. It's going to waste my time. I just say it is 1 divided by 3 all raised to the power of x. Just easy like that. Just easy like that. When they were, if you were given this and say find the inverse, you're just going to put log and just write it like that. Okay. Write down the equation of the asymptote of this one, of the inverse. Now, the inverse, it is an exponential function, which, and now the value of b, it is between 0 and 1, so it is a decreasing function, okay? So, but the asymptote, it is y should be greater than 0. Let me just prove it. The equation is going to be like this. Going to be like that, such that we have 0 and 1 here. Yes, and then if the this has a coordinate of 0 and 1, and then this will just be my function of the inverse. And then the asymptote, it is now this line, the x-axis. And the x-axis, it is y, it is equal to 0. Okay, y it is equal to 0. So my function is defined for y is an element of everything above 0. Okay, every value of y is greater than 0. So hence now this one. Or if in case you don't want to draw it, you can say, remember that the okay, no, I'm lying. This is this is the range that I did here. So it is y it is equal to 0. What I did was the range. So the equation is y it is equal to 0. So about that. Determine the, also draw the graph of the inverse on the same set of axes in the answer book. Clearly indicate the intercept with the axis, the coordinate of one other, blah, blah, blah. Okay, since we have already drawn it here. Okay, let me redraw it again. Ne? What I'm going to do, remember my inverse has a function, has a graph of 1 divided by 3 all raised to the power of x. So it is a decreasing function. Again, and now I know that the y-intercept will be 1 and 0. If the x-intercept it is 1 and 0 here, we flip that coordinate to be 0 and 1. And then the other coordinate again that I might flip it is 3 and -1, but in this case it's going to be -1 and 3. So I can put it here and say it is -1 and 3. Okay, these are easy things, guys, that everyone should be in a position of getting. Okay, and then the last question says, the graph of h is obtained when f -1, the inverse is translated 5 units to the right. Okay, so h of x is we get it when The inverse, it is translated x units to the right, so it is x minus 5. Remember, to the right is minus 5. Determine the y values of h where x is greater than 4. Okay, let's see. Let's see what is the equation of this one. It's going to be 1 divided by 3 to the power of x minus 5. So we want the values of y, okay? Determine the values of h where x is greater than 4. Where x is greater than 4, okay, what I want you to see is if you were to substitute 1 divided by 3 where x is greater than 4, let's say 5 minus 5, it's going to give you 1. And then when you substitute 1 divided by 3 to the power of 6 minus 5, it's going to give you something like 1 divided by 3. And then 1 divided by 3 to the power of 7 minus 5. It's going to be something like 1 divided by 9. So basically, it's everything starting from y is greater than 1. Okay, the values that you're going to get, the values of y that you're going to get are going to be always greater than y. And all the way to infinity. So therefore, the values of y are greater than 1. Or someone might say the values of y start from 1 all the way to infinity. I think you might include that. Okay? We might include 1 because it is also part of the solution. Okay, I'm not so sure, but yeah, I think you can include that. Okay, yes.